Another property that states that if you have a point outside of the circle, and if you were to draw two segments starting from that point, and those two segments are going to be tangent to the circle, then those two segments are going to be congruent. So we can write segment AB is congruent to segment CB. And we can take it a little bit further. Knowing that the radius is the same inside a circle, then those two segments are also congruent. And if I were to draw a segment from the center of my circle to the point outside of that circle, then they're sharing this side, that hypotenuse side. And so here we end up with two congruent triangles, right? And they're congruent by one of three reasons. We can say they're congruent by side, side, side. We can say they're congruent by side angle side, or hypotenuse leg. Either way, we have two congruent triangles, which allow us to do a little bit more. So here, the question is asking me to find the distance, or the length of SV. Well, to find that, we're going to have to use Pythagorean theorem. But before that, we have to figure out what is the side length, what is the length of that side, right? And so notice how they both of these segments are congruent because they start from one point and they are tangent. I know that they're tangent because they are perpendicular to the radius. And so we're going to start there. We're going to start by setting both of these equal to each other. And the first thing we're going to do is we're going to solve for x. So from here, we're going to subtract 4x on both sides. At the same time, we're going to add 41. So on the left side, I'm left with 6x. On the right side, I'm left with 48. Divide both sides by 6, and we get x to be 8. Once we know that x is 8, we simply substitute it back in there, and we have 4 times 8. So 4 times 8 is 32, and 32 plus 7 is 39. So this side here is 39, and this side here should also be 39. And so now I have enough information to go ahead and use Pythagorean theorem. Now it doesn't really matter which one I use because we have two congruent triangles, right? They're going to be the same information. Because if you notice, that represents the radius, which means that should also be 17. And now it doesn't matter which one I use. So here, SV, that's going to represent our C. And so we have C is equal to the square root of 39 squared plus 17 squared. And so we simplify that, and we get the square root of 1810, which is approximately 42.5. And so here, the distance of SV, or the length of SV, is 42.5.